Okay, hello again. We are going to do the next unit, which is about solving equations and basically about finding x-intercepts for functions that we want to plot. Okay, so this is section P5, the prerequisites section. And let's see here. Oops, new. So before we start that, we need to do a little review. First of all, here's a tough one. You ready? Square root of 4, what's that? You got to remember that's plus or minus 2, right? 2 squared will give me 4, minus 2 in parentheses squared, so I square the negative sign will also give me 4. So we have to be cognizant of the fact that whenever we take a square root, we're going to get 2 roots. Oops. Right? That's really important. We have to watch out for that. Secondly, if I do square root of 17 over 4, that's the same thing as square root of 17 over square root of 4, which is the same as square root of 17 over 2. We cannot leave a fraction underneath a square root sign. We can't have a denominator with a square root sign like this. I don't know why that's the rule, but that's the rule. You have to rationalize the denominator. That means you have to have a rational number down here. And something like square root of 2/3 is the same as square root of 2 over square root of 3. These are irrational numbers, meaning if you do square root of 2 on your calculator, you get 1.414 blah, 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 256. I don't remember what it is. But that number goes on forever. It never ends. It never repeats. It's considered an irrational number. And square root of 3, that's 1.7, blah, 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 blah. It goes on forever. It's an irrational number. And we are not allowed to have an irrational number in the denominator. So we always have to get rid of these. And the way we get rid of the square root of 3 is we multiply by square root of 3 over square root of 3. And what will we get down here in the denominator? Square root of 3 times square root of 3 is just 3. And up here, we'll get square root of 2 times square root of 3, which is the same as square root of 2 times 3, which is square root of 6 over 3. This is the proper form of this, okay? You cannot cancel anything between the 6 and the 3. You can't say that's really square root of 2 because a 3 here will cancel there. Nope, 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 can't do that because the 3 is under the square root sign. So this is the proper form of this square root fraction thing. You cannot have a fraction inside a square root. Okay, you always have to rationalize it. Okay. So now let's say, what's square root of 36 over 5? Well, that'll be square root of 36 over square root of 5. Square root of 36 we know is plus or minus 6, right? Square root of 5 is just square root of 5. Got to do something with that square root of 5. So again, multiply by radical 5 over radical 5. And that will give us plus or minus 6 radical 5 over 5. And this is the proper form of that, okay? In some cases, you'll know if we're trying to calculate a distance, you can't have a negative distance, so we just take the positive, okay? But there's certain instances where you would get rid of one of these 2 roots. But when we do it, we got to be careful about that. Okay, here's the big one. I'm going to use dangerous blood red here because I'm telling you, don't do this. I see this so many times. I saw this all through calculus. When I've taught advanced calculus, I've seen this. Don't do it. X plus 4 squared, what's that equal to? Oh, okay. X squared plus 4 squared, I remember, right? 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 No, it's not that. You cannot distribute an exponent across a sum. I'm going to be saying this all year long because people do it all the time. And I'll prove it. 1 plus 3 squared, is that equal to 1 squared plus 3 squared? 1 squared plus 3 squared would be 1 plus 9, 10. Wait, inside here, 1 plus 3 is 4. And we know what 4 squared is. Whoops, not 4 to the 4th. That's equal to 16, right? I know this to be true. I know this is the same as that. This is junk. You cannot distribute an exponent across a sum. You can never, never, never do that. If it's a product, if you're multiplying, then you can. Just like we did over here, right? We kind of distributed the square root across these two to mix them together there because it's multiplication. If this was addition, square root of 2 plus square root of 3, that's the best you can do. That's simplified. You can't change that, okay? Don't do this. I guarantee you there will be opportunities for you to do this on your first midterm because I want to see if you're watching this video and listening. Don't do this. Okay. So be careful about that. Okay, now let's say we have this thing, x squared minus 4x minus 5 equals 0. And we want to graph it, okay? Well, I know what the y-intercept is. When you're finding the y-intercept, you always put the other variable equal to 0. So if I plug x equal to 0, if this is equal to y here, x equal to 0, well, I'm going to get a y-intercept of minus 5. But now, forget the y equals 0 and let's, or y, and let's put it back equal to 0. So if I want to solve this for x, I have to factor it, and I have to use the FOIL method to factor it. So I'm going to take this and look at the factors of the last number over there. So it's -1 and 5, 1 and -5. Multiply those together, I'm going to get that. Which pair will add up to give me this, -4? Let's see, this pair. So I'm going to write this as x plus 1, x minus 5 equals 0. And now I can check to see if this is the same as that. So first two, that's the f, x squared. Outside 2, minus 5x. Inside 2, that's those, plus x. Last 2, minus 5. So this gives me x squared minus 5x plus 1x is minus 4x minus 5 equals 0. So sure enough, that's the same as this. So this is the factored form of the top equation. And notice I did my little graphical reminder to make sure I'm capturing all of the factors of this. I do this every time I do FOIL. I found whenever I draw these arcs and I do that, I never miss one and I always get it right. So I always do that, and I highly encourage you to do the same. So there's a rule about products when two things multiplied together, x times y equals 0. The only way this is true is if x is equal to 0 or y is equal to 0. So up here, if I want this thing equal to 0, well then, if it's factored here, this means x has to equal to -1 or x is equal to 5. These are the two solutions. Oops, that was kind of ugly. These are the two solutions for this equation up here. I want to remind you of that so we can do it. And also, we can go the other way. Instead of factoring, we can multiply out. X plus 2, x plus 3. So we're going to use FOIL. First 2, outside 2, inside 2, last 2. X squared plus 5x plus 6. So this is the same as that. This is in factored form. This is with the factors multiplied out. Okay? We need to remember to do that. So we need to watch out for that. Because we're going to do this sometimes. Okay? Now, solving a quadratic equation. A quadratic equation is ax squared plus bx plus c equals 0. And there's 3 ways that we can solve this. Not all of them work. Usually they do. Number 1 is factoring. And that's what we just did. Number 2 is completing the square, which we're going to work on. And number 3 is the quadratic equation that nobody likes because it sucks to do it on a calculator. We're in an online class, so we're going to probably use some other tool. But so we talked about this already. Let's talk about completing the square. Okay. First of all, recall if you had x plus 2 squared equals 3. One way to solve this is to multiply all this stuff out, move the 3 to the other side, and hope it's factorable. It won't be. Okay? But let's do that for fun. So x plus 2 times x plus 2 equals 3. Outside 2, or first 2, outside 2, inside 2, last 2. So x squared plus 4x plus 4 equals 3. Now I'll subtract 3 from both sides. X squared plus 4x plus 1. And what are the factors of 1? Well, it's 1, 1, -1, and -1. None of these add up to give us a 4. We can't factor this. So that means we'd have to go to use the quadratic equation or something. So I'm going to show you another way to do it. So I can take this thing. Let me get rid of that line. That annoys me. Okay, good enough. So another thing we can do is take the square root of both sides. You got to be careful. Sometimes when you take a square root, you end up losing one of your solutions. So you always got to be careful. But what's the square root of something squared? What's the square root of 2 squared? Well, the square function and the square root function are inverse functions of each other, and they kind of undo each other. So you're just going to get whatever the argument is inside. Okay? So the same thing here. I'm just going to take the square root of the square, and I'm just going to get x plus 2. But then over here, and I generally don't get a plus or minus sign because I'm going to take care of the plus or minus sign over here. Oh, wait, let me change this. Sorry. Let me change this to 9 so we get something over here, right? Yeah. Sorry. There, so make this a 9. X plus 2 squared equals 9. When I take the square root, we get plus or minus 3. Then I solve for x. X equals, we'll subtract 2. So it'll be minus 2 plus or minus 3. So I'm going to get minus 2 plus 3 is one solution, or minus 2 minus 3 is the other solution. So this would be positive 1, and this would be negative 5. So I can take the square root of both sides, make sure this side becomes a plus or minus. If it's x squared, there's two solutions. Oops, let me move me. There we go. Two solutions. See, 1, 2. There's two solutions when I have an x squared. If it's x cubed, there's 3 solutions. So this is one way to solve it. Let me do another. So x minus 4 squared equals 5. So I'll take the square root of both sides. I mean, we could try multiplying it out, but it doesn't always work. Sometimes it does if you're really, really lucky, but I can't imagine we are. So this will give me, when I take the square root, x minus 4 equals plus or minus the square root of 5. Okay? So now I got to add 4 to both sides. X equals 4 plus or minus square root of 5. So one solution is 4 plus radical 5, and the other solution is 4 minus radical 5. So I took the square root because I had a perfect square over here, which was x minus 4 squared. I can take the square root and get rid of that square, but I got to square root the other side of the equation. Okay, so now let's get to the fun stuff, completing the square. I, oddly enough, enjoy completing the square. I don't know why. So let's get a pretty color. There we go. A little royal purple. So let me remind you that if I have a plus b squared, that's the same as a squared, oops, a squared plus b squared. Is that right? Is it right? Raise your hand if you think that's right. No, of course not. You cannot distribute an exponent across a sum. So this is not correct. I'm going to get rid of that too, because I would have to write this as a plus b times a plus b. And then first 2, a squared, outside 2 plus ab, inside 2 plus ab, last 2 plus b squared. So this is a squared plus 2ab plus b squared. Okay? So now let's try one with an x. Remember, these arcs are really important for you to get in the habit of doing. It will help you to not make mistakes on multiplying polynomials. So let's do x plus 6 squared. So that's going to be x plus 6, x plus 6. So x squared, outside 2 plus 6x, inside 2 plus 6x, last 2 plus 36. X squared plus 12x plus 36. I want to draw your attention to the fact that this number here is always half that number there. So if I take anything, x squared plus 8x plus 16. I could write this as, I made it so that it's x plus 4 squared. Half of this number is going to be that. And this number is always that one squared. Always. So you see, this number is 6 squared. is half of this number squared. So if I have a thing, x squared plus bx plus, well, that's a crummy way to do it. So let's keep that in mind. This number is always half of that one. And it's whatever half of this number squared is always going to be the last number. So let's do an example to see how the patterns work. And I haven't talked about patterns yet, but I have learned that math is all about patterns. And if we can remember the patterns, then we have an easier time with this stuff. So x squared plus 4x equals 6, okay? If I bring the 6 over here, this is not factorable. X squared plus 4x minus 6 equals 0. The factors of 6 are minus 1 and 6, 1 and negative 6, negative 2 and 3, 2 and negative 3. These will add up to 5, negative 5, 1, negative 1. None of them give us a 4. So this cannot be factored. It is impossible. But we can use our strategy of completing the square to solve this equation. And the way we do completing the square is, let's get rid of this as well, because I'm going to give you some steps. Okay, we take the middle number, number 1. Oh, you get x's on one side and the constant on the other. Okay, we already have that. Number 2, take 1/2 of the coefficient on x. Okay, so 4. So 4 over 2 is 2. Then square it. Okay, so 2 squared equals 4. Add to both sides. So, okay, so this will become x squared plus 4x. So I did half of 4. Half of 4 is 2, and I squared it. 2 squared is 4, so I'm going to add 4. Okay. Now, oops, going backwards. Write in x plus b squared form. So when I did this, when I took half of that number and then squared it, I forced this thing to be a perfect square. And the perfect square is going to be x plus whatever this number was squared equals 10. So if this was x squared plus 8x equals, I don't know, 12. So half of this number is 4. 4 squared equals 16. So I would do x squared plus 8x plus 16 equals 12 plus 16. And this thing is automatically, remember this number here we took? It's going to be x plus 4 squared equals 28. So this is how completing the square is. I'm forcing one side to be a perfect square by taking the coefficient of x right here and dividing it by 2, squaring it, and adding it to both sides. By doing these steps, I'm able to write the equation in the form x plus a constant squared. And so that's what I did here. Oops. And then if I continue this, I'm going to take the square root of both sides. Square root of that, square root of that. We'll get x plus 2 equals plus or minus square root of 10. And then x, I can subtract 2 minus 2 plus or minus square root of 10, which means one solution is minus 2 plus square root of 10, and the other solution is minus 2 minus square root of 10. So by taking half of this number, taking half of that number, here it is, right here, and squaring it, oh, here it is here, then I add it to both sides. It makes this thing a perfect square, x plus 2 squared, so that I can take a square root and make the square go away and put a square root on the other side. So down here, if we look at x squared plus 8x equals 12, so now I would take a square root and I would get x plus 4 equals plus or minus radical 28. X equals minus 4 plus or minus square root of 28, which means the solution to this equation are minus 4 plus square root of 28 and minus 4 minus square root of 28. You might be asking, why do I got to do minus 4 plus 28, minus 4 minus square root of 20? Because it's plus or minus right here. So I'm spreading those two solutions out so I can see them both easily. One of these might be invalid because I can't have a negative answer for some reason. I don't know why. Maybe the question says you don't want to. And so maybe I throw one away. So I like to spread them out so I can see them. This process, these are the steps for completing the square. If you follow these steps on a completing the square problem, you will always get it right. You can't help but to get it right. Okay? A lot of people hate completing the square. I find it easy. It's much easier than plugging into the quadratic equation because that sucks. So let's see. Let's try one here. X squared plus 10x equals 0. Now, completing the square here is a really poor choice because I can factor this. I can pull an x out and it would leave behind x plus 10, right? I could factor an x from both terms. If I multiply these two, I get x squared, and those two, I get 10x. And so this would say this one factor, that one, x is equal to 0 in order to make everything 0, or this factor, x plus 10 equals 0. So our solutions would be x equals 0 and negative 10. So that's what I anticipate we're going to get over here. Okay? So let's take this, let's use the completing the square process. The first step is to get the x's on one side and the constants on the other. We already did that. Now we take the coefficient on x and divide it by 2, and then I square it. That's the number we're going to add to both sides of the equation. So this will be x squared plus 10x plus 25 equals 0 plus 25. Okay. Now this thing can be written as a perfect square. X plus this number. If this was a negative sign, then this number would be a negative 5 if this was a negative 10. Right now it's not, so it's just a 5. Whoa, what am I doing? There we go. So x squared plus 10x plus 25 is the same as this. Ah, you don't believe me, huh? Okay, you can call me a liar. I'm okay with that. So we're going to FOIL it. X squared, outside 2, inside 2, last 2. So x squared, these would give me a plus 10x plus 25. So you see, in this instance, I am not a liar. No guarantees about any other instances. Okay. Now I take a square root of both sides. So x plus 5 equals square root of 25 is plus or minus 5. So x equals, I'll subtract 5 to both sides. So it would be minus 5 plus or minus 5. So this means one solution is x equals minus 5 plus 5. And the other solution is x equals minus 5 minus 5. Oh, wait, this is 0, and that's negative 10. Look at that. We got the same thing as we got over here. So completing the square, factoring. Factoring is always easier. But if you can complete the square, it makes it very convenient. Okay? So let's try another one. Here is 4x squared minus 20x plus 17. This looks really inconvenient. So get everything on one side, x is on one side, everything else on the other. So I minus 17, 4x squared minus 20x equals 17. And then I'm also going to divide by 4 because this is going to mess things up. So I'm going to divide everything by 4. So x squared, 20 over 4 is 5. Now I got to do my thing. And this really sucks because this is an odd number now. But I'm going to take 5 over 2, and then I'm going to square it. Right? I take half of this number and square it. Oop, minus 5 over 2. And then square it. So I get minus 25 over 4. So that's what I'm going to add to both sides. X squared minus 5x minus 25 over 4 equals minus 17 over 4 minus 25 over 4. So this thing is a perfect square because I forced it by doing the completing the square process. And I could write it as x. And you remember the thing we chopped in half? That's what goes in here. And minus 17 minus 35. What's 17 plus 25? So that'd be 2, carry the 1, so that's a minus 42. Now what? Oh, I got to get rid of the exponent. Square root, square root. So this will be x minus 5 halves equals, oh, what did I do? Oh, I did it wrong. You didn't catch me. Because we can't take the square root of a negative number, right? So this 5 over 2 squared is not negative 25 over 4, it's plus, right? Whenever you square something, the negative sign goes away. Why can't I erase that? There we go. So I should have added 25 over 4. I did that on purpose, just as a demonstration of possible mistakes. Yeah, that's it. So x squared, I guess I could edit it out, but I really don't care. It's good to see mistakes. X squared minus 5x, so I add 25 over 4 equals negative 17 over 4 plus 25 over 4. So this thing becomes x minus 5 halves, because 5 halves is the number that we cut in half. It was half of this number. Squared equals, now I got to do 25 minus, minus 17, so that'll give me 8, right? Yep. Equals 8 over 4, which is 2. Now I take the square root of both sides. So I get x minus 5 halves equals square root of 2. Oops, plus or minus. X equals, I add 5 halves to both sides. So I'll get 5/2 plus or minus square root of 2. So do I need to rationalize this? Do I need to do anything with this? I don't, because there's no fractions in the denominator. If I had a fraction in the denominator, then I'd have to clean that up. So this is 5/2 plus radical 2, or 5/2 minus radical 2. These are going to be the two solutions to this equation. So this is completing the square, a very powerful way to solve for x in a quadratic equation. Now the other way, the last way, and I only got a few minutes, I don't know if Zoom's going to knock me out or not, is to use the quadratic equation. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And this is assuming an equation looks like ax squared plus bx plus c equals 0. This is referred to as the standard form. And you got to get the equation in this form before you can ever use the quadratic formula. So let's say it's 3x squared minus 4x minus 8 equals 0. So here's what I do to keep from making mistakes. I strongly, strongly, strongly urge you do this. A equals 3, B equals minus 4, C equals minus 8. Yeah, I know, I hear you. I don't have to do that. That's dumb. I used to do that in high school. I'm telling you, it's going to keep you from making mistakes. I've been doing this a long time, and I know. Okay, x equals. Now, here's the other thing that people have problems with. They will go like this, and they'll go minus b, so minus a negative 4 plus or minus the square root of b squared minus 4 times a times c all over 2a. Well, this looks like this thing isn't even under the, it's part of the fraction. It looks like it's its own thing sitting out there, and it's very common for people to treat this as the fraction, and this is just standing out here on their own. And so when you do this, when you do the quadratic formula, here's my second tip. So make a long divisor line. If it's too long, nobody's going to care. Minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times minus 8. So now we can go through and multiply this stuff out and figure out what this equals. Okay? The thing I don't like about the quadratic formula is there's a lot of opportunity for negative sign errors. And so we got to be really, really careful about that, right? There's a negative sign here that people frequently forget. There's a negative sign here, a subtraction that people frequently forget. And look at all these negatives we got floating around. Man, this is a nightmare because you got negative signs here and here. So using the quadratic formula can be a mess. This thing's, if you try to do this with completing the square, it's going to suck just as much, if not more, because you're going to, when you divide by 3, you're going to get a whole bunch of fractions. And so doing it with completing the square is not fun. Probably the quadratic formula is the way to treat that. But that's basically the way they go. So I will come back with some more videos to show you some example problems, okay? So sit tight and I'll be back.